Let's take a look at an inductive dropper. So I'm going to try to light a blue LED up at 20 milliamps at 3 volts with an AC source over here. So I need 3 volts to drop across this blue LED. So in order to do that, I'm going to put 4 volts into this side of the 4 volts RMS into this side of the rectifier and hope to get 3 volts out over here. So now, normally if we put in, say 12 volts RMS value into this rectifier, we're going to get about 15 volts DC out, okay? And 12 volts RMS is the same as 12 volts DC into a resistive load, but we get a higher DC voltage out of a rectifier, okay? And the reason for that is that here's our sine wave coming out of a rectifier, and we have these peaks up here, and then we have a capacitor that's trying to smooth that out, okay? And our RMS value is down here, so the DC value is up higher. Now, in order to find this ripple here, we take the peak voltage times the time divided by the RC, which is this capacitor here and whatever load you have over here. Okay, so the time now is, this one happens to be 60 hertz, so we take 120, this is doubled up, in divided into 1, it's 0.0083 seconds, okay? So we take our peak voltage times our seconds divided by our RC here. So our peak voltage is equal to 1.414 times 4 volts in this case. I'm putting 4 volts in over here, trying to get 3 out here. And we divide that by our 150 times the capacitance, and it comes out to 3.126 volts. We have to cut that in half, and that comes out to 0.1563 volts, and we subtract that from our peak value, which is our 1.414 times our 4 volts, and that peak value is 5.65 volts. So when we do that, we come up with 4.093 volts, okay? So a little higher than the voltage coming in, but now we'd have to take the diode drop out, okay? So if this was 120 volts AC coming in here, you know, our diode drop is only about 1%, and our 12 volts, it's about 10%, but for 4 volts, this diode drop is about 30% of the 4 volts here, the 1.2 volts. So when we take that voltage drop across out of there, it comes out to 2.86 volts. Now it could be a little higher if this is 1.4 volts, then it's going to be a little bit higher than that. So we're going to get our if we put 4 volts in here, we're going to get our 3 volts out over here. So now, and we're going to put 12 volts over here, so we got to drop 8 volts across this inductor here. So we find the inductive reactance, so our ohms are going to be equal to 12 minus 4, which is going to give us our 8 here, and divide it by our load of 20 milliamps. So that's going to be 400 ohms. So we know our inductive reactance is 400 ohms. To find the henries, we can just take this formula and we massage that around a little bit to get this formula. So L is equal to our 400 ohms over our 2 pi times the frequency. So we take our 6.28 times 60 into the 400 ohms, and we get 1.06 henries, okay? So if I put a 1 Henry inductor up here and 12 volts AC here, I should get 4 volts here and 3 volts over here. Now, the reason I'm not doing this with 120 volts AC is, first of all, it's not all that safe, but if I went with 120 volts here, I need a 15 Henry inductor over here. Now, 15 Henry inductor is quite large, and they're about $40. So I went with a 1 Henry one that I had, and they're about $10. So we're going to see if it works. Yep. Can we see that? I'll turn it on. Yeah, our blue LED comes on, and then let's turn this on. What do we have for voltage? 1.69. So maybe we were dropping 1.4 volts across that bridge rectifier there, and then we'll put this to AC, and let's see what our AC is here. So we got 12 12.18, a little bit higher. And over here we should have probably a little higher than that. Yeah, 4.3 volts. Okay. And then we have our say 2.7 across the LED. So it's working. Like I say, this might be a little higher, and my inductor here probably not quite 1.6 Henrys, of course, and but it works, but it's not practical because, you know, this thing's large, and especially a 15 Henry one would be a lot larger than that. And for 20-cent capacitor, you can do the same thing with a capacitive dropper. So we always go with a capacitor dropper. There's some cases where you use an inductive dropper, but not too often. Anyway, it does work, and that was the math for it. It came out fairly close. This is probably pretty good. Lights lit up, the LED's lit, so we're good. Thank you. That's it.